Welcome to BCE Digital Learning Session. I am Dr. Shobhan Kumar, Assistant Professor, working in Department of Mathematics, Maharani Science College for Women, Bangalore. Today I have to discuss Crout's LU decomposition method. In earlier classes, already we know that solving the simultaneous system of equations by using two methods. One is a direct method, another one is a iterative methods. Under a direct method, Gauss elimination method, Crout's LU decomposition method, and Cholesky method. Already yesterday we discussed Gauss elimination method. Now I have to discuss how to solve the simultaneous equations, system of simultaneous equations, or system of linear equations by using Crout's LU decomposition method. Introduction. First, we know the triangularization method. There are two methods in triangularization method, namely LU decomposition method, Crout's LU decomposition method, and Doolittle LU decomposition method. The triangularization method is also known as a decomposition method or factorization method. In this method, the coefficient matrix A of the system of equation Ax is equal to B is a decomposed or factorized into product of a lower triangular matrix L and a upper triangular matrix U. Therefore, A can be written or factorization or decomposed L into U form. A is equal to LU. Here L is a lower triangular matrix and U is upper triangular matrix. Where L is equal to L11, 0, 0 and so on 0 in first. Second row, L21, L22, 0 and so on 0 and so on Ln1, Ln2, Ln3 and so on Ln. That means lower triangular matrix means all the entries above the main diagonal should be 0, 0. And the upper triangular matrix U is equal to U11, U12, U13 and so on U1n. 0, U22, U33 and so on U2n. 0, 0, U33 and so on U3n and so on 0, 0, 0, UNN. This is upper triangular matrix. In upper triangular matrix, all the elements under main diagonal should be 0. This is a lower triangular, this is upper triangular. Here, according to Crout's method, first we decompose the coefficient matrix into lower triangular matrix and upper triangular matrix. Now, multiply matrices L and U and comparing the elements of resulting matrix with those of matrix A, we get Li1 Uij plus Li2 U2j plus and so on Lin Unj is equal to Aij. Here j varies from 1 to n, where Lij is equal to 0 when j greater than I and Uij is equal to 0 when I greater than j. Here Lij is equal to 0 when j greater than I and Uij is equal to 0 when I greater than j. This is one. The system of equation involves n square plus n unknowns. Thus, there are n parameter family of solutions. To have a unique solution, we choose conveniently either Uii is equal to 1 or Lii is equal to 1. I varies from 1 to n. If we choose Lii is equal to 1, then the method is called Doolittle method. Uij is equal to 1, then the method is called Crout's method. That is called Crout's method. Here, this is not, here in this case, j is equal to I. J is equal to I, here, this is I. Ui is equal to 1. Okay. Now I have to discuss how to solve the system of linear equations by using Crout's value decomposition method. Consider the system of three linear equations in three unknowns. A11x1 plus A12x2 plus A13x3 is equal to B1. A21x1 plus A22x2 plus A23x3 is equal to B2. A31x1 plus A32x2 plus A33x3 is equal to B3. This is a given system of linear equations. The system of equation 1 can be written in the matrix equation Ax is equal to B form. Already we know that in earlier cases where A is coefficient matrix of 1, A is A11, A12, A13, A21, A22, A23, A31, A32, A33, coefficient matrix of 1. And X is here three unknowns, X1, X2, X3, and B is right hand side of given system, B1, B2, B3. Now we can factorize the coefficient matrix A as the product of lower triangular matrix L and upper triangular matrix U. That is, A is equal to LU. A is equal to LU. Here put A is equal to LU. In AX is equal to B, we get LUX is equal to B. LUX is equal to B. Here L is a lower triangular matrix and U is upper triangular matrix. Where L is equal to L11, 0, 0, L21, L22, 0, L31, L32, L33, and U is upper triangular matrix, U11, U12, U13, 0, U22, U23, 0, 0, U33. Here, all the entries should be 0 above the main diagonal. Here, all the entries should be 0 below the main diagonal. Now, for Crout's LU decomposition method, we have choose U11, U12, U13 is equal to 1. That means here UII, here 1 is equal to 1. Here U22, U22, and here U33. U33 is equal to 1 because UII is equal to 1 is nothing but Crout's method. UII is equal to 1 is called Crout's method. LII is equal to 1, that becomes Doolittle method. Here we choose U11 is equal to 1, U22 is equal to 1, U33 is equal to 1. Then upper triangular matrix U becomes 1, U12, U13, 0, 1, U23, 0, 0, 1. Let us consider according to Crout's method, consider LZ is equal to B. We take L into Z is equal to B. L is, we know that, lower triangular matrix. Z is Z1, Z2, Z3, and B is B1, B2, B3. Now L is a lower triangular matrix, and we can expand it. Here L into Z, and equating corresponding elements in right hand side, we get three equations. L11 Z1 is equal to B1. L21 Z1 plus L22 Z2 is equal to B2. L31 Z1 plus L32 Z2 plus L33 Z3 is equal to B3. We can find the values of Z1, Z2, Z3 by forward substitution method. Here from this we get Z1 directly, put Z1 here, we get Z2, and again put Z1 and Z2 in last equation, third equation, we get Z3. That's all. After getting Z1, Z2, Z3, we found the matrix Z by using Ux is equal to Z. You should remember Ux is equal to Z, obtained by the unknowns X1, X2, X3. Here Ux is equal to Z. Z is known. Here we can expand it and equating the corresponding element in right hand side. We get three equations, and by back substitution, we get X1, X2, X3. This process is known as the finding the unknown by using this process is known as Crout's LU decomposition. Once again, you should remember, first note down the coefficient matrix and decompose the coefficient matrix in the product of lower triangular matrix and upper triangular matrix, and then in Crout's method, choose U11, U22, U33 is equal to 1, the upper triangular matrix in this form. Let us consider LZ is equal to B, L is a lower triangular matrix, and expand it and equating the corresponding elements. Here we know that here B1, B2, B3, B1, B2, B3, and by forward substitution, for forward substitution, we get Z1, Z2, Z3, and again we assume Ux is equal to Z. U is upper triangular matrix, we know that, and X is unknowns, and Z we know that, Z1, Z2, Z3, substitute here and expand the left hand side and equating the corresponding element in right hand side, we get three equations. By back substitutions, we get x1, x2, x3. Now we consider one example. Solve the system of linear equations by using Crout's LU decomposition method. The equations are x1 plus x2 plus x3 is equal to 1, 4x1 plus 3x2 minus x3 is equal to 6, 3x1 plus 5x2 plus 3x3 is equal to 4. Here this is the given equation, call it as 1. And note down the equation A, coefficient equation of the given system, and unknown matrix X and constant matrix P. Here, now decompose A into upper triangular, the product of upper triangular and lower triangular matrix. Here A is equal to L into U. L is L11, 0, 0, L21, L22, 0, L31, L32, L33, and U11, U12, U13, 0, U22, U23, 0, 0, U33. According to Crout's LU decomposition method, in upper triangular matrix, we choose U11, U22, U33 or 1. Therefore, here, substitute here, we get 1. Okay, here 1. Now, in right hand side, L into U, take the product. Here, you can write down here L into U. Here, L11 into 1. L11 into 1 plus 0, it becomes L1. First row into first column. Okay, first row into second column. L11 into U12 plus 0 into 1, 0 plus 0 into 0, and so on. We get L11, L11 U12, L11 U13. Second row is L21, L21 U12 plus L22, L21 U13 plus L22 U L23, and last row in right hand side L31, L31 U12 plus L32, L31 U13 plus L32, L32 L23 plus L33. Now equating the corresponding entries in left hand side, we get L11 is equal to 1, L11 U12 is equal to 1, L11 U13 is equal to 1, U12 is equal to 1, U13 is equal to 1, L21 is equal to 4, L21 U12 plus L22 is equal to 3, L21 U13 plus L22 U23 is equal to -1. And from these equations, here we know that here L21 and U12, put L21 and U12 here we get L23. Like this, we get all the values of L11, L21, L22, L23, L32, and L33, and U12, U13, and so on, U13. That means L is equal to 1, 0, 0, 4 minus 1, 0, 3, 2, and 10. And U is equal to 1, 1, 1, 0, 1, 5, 0, 0, 1. Now by using LZ is equal to B, L into Z is equal to B. LZ, L is a lower triangular matrix, Z is column matrix Z1, Z2, Z3, and B, here we know that from the given equations 164. Now expand the left hand side and equating the corresponding element in right hand side. Here we get three equations. Z1 is equal to 1, 4Z1 minus Z2 is equal to 6, 3Z1 plus 2Z2 minus 10Z3 is equal to 4, by forward substitution, we get Z1 is equal to 1, Z2 is equal to minus 2, and Z3 is equal to minus 1 by 2. Therefore, Z1 is 1, Z2 is minus 2, Z3 is minus 1 by 2. Now, by using the equation Ux is equal to Z, U is a triangular matrix. We know that X is X1, X2, X3, and Z is Z1, Z2, Z3. We know that here the values of Zi's. Therefore, Ux is equal to Z. Here U, X, and Z. Now expanding the left hand side and equating the corresponding element in right hand side, we get three equations. X1 plus X2 plus X3 is equal to 1. X2 plus 5, X3 is equal to minus 2. And X3 is equal to minus 1 by 2. By back substitution method, we get x2 is 1 by 2 and x1 is 1. Therefore, x1 is equal to 1, x2 is equal to 1 by 2, x3 is equal to minus 1 by 2. Our required solution of the given system of linear equation according to Crout's LU decomposition method. Now consider another example. X plus 5y plus z is equal to 14. 2x plus y plus 3z is equal to 30. And 3x plus y plus 4z is equal to 17. Here now, first note down coefficient matrix A and decompose the coefficient matrix into product of lower triangular and upper triangular matrix. In Crout's LU decomposition method, we choose U11, U22, U33 are 1 here, substitute here, and take the product of right hand side and equating the corresponding elements in left hand side. Here in coefficient matrix, we get number of equations, solve them, and we get all the values of L11, L21, L22, L31, L32, L33, U12, U13, U23, and here we have L upper triangular matrix and U upper lower triangular matrix and upper triangular matrix. And now consider according to Crout's LU decomposition method, Lz is equal to B, and we know that L is upper triangular matrix and B is from the given system of equations, and expand it and equating the corresponding elements, we get three equations by forward substitution method. We get Z1, Z2, Z3. Z1 is 14, Z2 is 5 by 3, and Z3 is 3. And again consider Ux is equal to Z, and U is upper triangular matrix. We know that, and X is XYZ, and Z is Z1, Z2, Z3. Z1, Z2, Z3, and expand the left hand side and equating the corresponding elements in right hand side. We get three more equations here by back substitution method. Here Z is equal to 3 and Y is equal to 2 and X is equal to 1. Therefore, X is equal to 1, Y is equal to 2 and Z is equal to 3 are required solutions of given system of linear equations. Okay, I hope you well understanding how to solve the system of linear equations by using Crout's LU decomposition method. It is a very simple. Here, the first note the coefficient matrix from the given system of equations and decompose the coefficient matrix into the product of lower triangular matrix and upper triangular matrix in Crout's LU decomposition method. In upper triangular matrix, we choose UII is equal to 1. That means U11, U22, U33, and so on, UNN is equal to 1. Put these values in upper triangular matrix, and expand and take the product in right hand side and equating the corresponding element in left hand side. We get number of equations, solve them, and we get finally we getting lower triangular matrix and upper triangular matrix, and according to Crout's LU decomposition method, we take Lz is equal to B. And we getting Z, Z1, Z2, Z3, and so on, Zn. After getting Zi's, We use we use uz is equal to ux is equal to z. Here ux is equal to z. X means the number of unknowns in the given system of linear equations, and expand the left hand side and equating the corresponding elements in right hand side. By that substitution, we get unknowns x, y, z, and so on. It is a very simple, and here number of exercises are there. Do yourself and go through the references. Okay, let me start the stage.